The GCSE exam is very fond of these questions where a sequence is linear. Now the word linear is a bit unhelpful there. It basically means that if you graphed it, it would be a straight line. But the on the ground meaning for you is that the gap doesn't change. So it's 3, 3, 3. Okay? And this video is just about how to answer questions where that arises naturally from a context problem, from a problem about the real world. So here's an example. My daily pay starts at £100 and rises £10 per day until 30 increases have occurred. Whereupon it stays the same. How much do I earn over the first 100 days? Okay. Right, now this is a tricky little question. It's going to use most of our machinery. Now, for questions about sequences, we always advise just writing out the sequence. This is the sequence of pays. Just write it out just to get your head in the groove. Okay. Now, your machinery requires you to think about positions, so no harm at all in writing the positions up the top. But additionally, we've been asked about increases. So that's position, that's pay, and this is number of increases. Okay, I'm just writing this down because I'm preparing for being asked about it. Okay, so how many increases have occurred there? 0. How many increases have occurred there? 1. How many increases have occurred there? 2. Okay. Okay, now we have more than enough to get our machinery going. Okay, so nth equals 10n. Does that work? If I put a 2 there, I should get the second term. If I put a 2 there, I get 20, where I should get 110. So that's my rule. Let's just check that works. If I put a 3 there, I get 30 plus 90, which is 120, so that's working nicely. Okay? Now, what can I do with this? Okay, well, I can use it to find out when the pay stops rising. Okay? Now, the pay stops rising when there have been 30 increases. Okay? So in other words, when there's a 30 here. Okay? Now, I don't know what that figure is yet, but I can be 100% sure that the position is always 1 more than the number of increases. So if that's a 30 for the count of increases, that has to be a 31st for the position. The reason I'm interested in a 31st for the position is that anything with a suffix on it, an ST, an ND, a TH, or an RD, can go there. Okay? So I put that there. So the 31st equals 10 times 31 plus 90, which is 310 plus 90, which is 400. So that's a 400. Just write out the sequence to get in the groove, etc., etc. Maybe even work backwards just to get myself even more in the groove. Okay, and now I've got plenty of details. So now I'm ready to answer the question. The question is, what do all these add up to? Okay, well, I'm going to do it in categories. Okay, I'm going to do, the first category is 31 days of increases. I'm going to ask, what does that add up to? Okay, then I'm also going to do 69 days of non-increases. Okay, so that's all the ones after that. Okay, now the pay each day for the 69 days of non-increases is 400. So that should be easy enough to work in my head. Times by 4, you just double twice. So that's 138. Then 276. Okay, so that's the first category. Now, this 31 days of increases, this is a classic example of how you should do things in the order that's convenient for you, not just the order that things are written. Multiplication is commutative, remember, therefore you can do it in whatever order you like. Okay, now here's the clever thought. Instead of just adding this, plus this, which would take forever, I'm going to add this and this. Then I'm going to add this and this. And then I'm going to add this and this. Now the geniusness of that is that those figures, those answers are all the same. They all add up to 500. So all I need to know is how many pairs there would be. Okay? So there's the total of each pair. I'm now going to times by the number of pairs. Okay? Now the number of pairs is just half of whatever number of terms there were. Okay? Now how many terms were there along here? There's 31. So actually there would be an odd one out. What should we do? Okay, let's do 500 times the number of pairs, which is 15. I've taken out the odd one out and then I've halved it. And then I'm going to add the odd one out. Now the odd one out has to be what's halfway between those. Okay? So 500 times 15 is 7,500. So the grand total is 7,750. Add those two up and that's your grand total. So just to recap from this example, what are some of the things we've learnt? We've just written the sequence out until you're in the groove, adding some extra detail later. We've learnt the value of putting your own information onto the table to help you translate between what you're asked, which is increases, and what you're comfortable with, which is the positions. We've also learnt the value of adding things up in the order that you prefer rather than the order you're given. Here I've done this very clever thing of adding up from the first and last, the second and the second last. And of course, this is an example of how it's often clever to do things in different categories.